it's not so easy to be sure whether it's all the signals we see are to be attributed to climate change. And there are some recent studies that, for instance, show that glaciers worldwide, they have, for the time being, as a collective of 200,000 individual glaciers, they have only a 60-70% response to anthropogenic changing, because the other 30-40% are still a recovery from Little Ice Age. So they had been so big during the Little Ice Age that they are still, and they have a long memory. So they have still a little bit of memory to this Little Ice Age, end of the Little Ice Age. And that is mainly the big glaciers in the Arctic. It's not the small glaciers which we have in the mountain regions. For instance, in the Alps, the same exercise shows that there is absolutely no memory anymore from Little Ice Age. It is all anthropogenically caused. This is one of the major new findings. We have another point which is almost weekly or monthly news that we get from West Antarctica, where huge pieces of ice shelf are breaking off due to melting underneath from changing water circulation, seawater, and then this shelf ice is thinning and loses the contact to a small number of pinning points, and so it breaks off. And the consequences is something which was still unexpected to a certain extent, is that the outlet glaciers from the huge inner ice fields in Antarctica, they have accelerated immediately after these break-offs of this floating part of the ice. And there is some concern, serious concern, that parts of the West Antarctica are becoming unstable, and that there is major changes, major ice discharge into the ocean being triggered by this, the break-offs of the fringes of the ice, and this is something which is quite concerning. And we have just to think that in West Antarctica alone there are 7 meters of sea level equivalent stored. The other thing is that Greenland keeps on melting quite heavily, and the sea ice extent in the Arctic is still decreasing rapidly. Snow cover is something which has a very high variability. Therefore, it also is not so easy to really detect a change, but there is also change in the extent of the snow cover. Sea ice in the Arctic is quite drastically decreasing. We know that already since a while, and it still continues to decrease. It also thins, not just in extent, it is decreasing also in thickness, which makes it even more sensible to small changes. After all, there is, in regard to the cryosphere, there's a certain threshold. And the threshold is 0 degrees, the melting point. And you may not note big changes in temperature, in air temperature, for quite a while. And this is, for instance, in parts of Antarctica, where obviously the temperatures have risen quite considerably, but the effect is not yet that strong, because we are still far or considerably below freezing point, or melting point is in this respect a better word. But as soon as the melting point is reached, then it is kind of a change in gear, and the effects are then being very, very visible and strong.